All right, ladies and gentlemen, we are going to do day 2 here, dealing with these percentages and percent of change. So we're going to start with 2 warm-up questions here. I would like for you to pause the video here and complete this first question about the girls' dress shopping. Unpause it when you're finished to see the answer. All right, so if we take a look, girl number 1 is going to get her dress for $60. That means she got $15 off. Girl number 2 is going to get her dress for $59.50, which means that she got $25.50 off her dress. Which girl is getting the better price? Girl number 2 is getting the better price by 50 cents. All right, next warm-up problem. I would like you to go ahead again, pause this video, and see if you can see who is correct, either Maddie or Xavier. Notice they're finding the percent of change here. The original amount was 25 and the new amount is 28. So again, go ahead and pause and see who is correct. Maddie is correct because if you remember, the formula is to do the change over the original. It changed by $3, which they both got correct. But the original price is original amount was $25. So that means Xavier put the correct original amount in the denominator of his fraction. So he is correct. It is a 12% increase. Okay, moving on. An online retailer conducts a random survey of its customers. The survey shows that 80% of the customers who receive their packages within 4 days and 95% of those customers are satisfied with the quality of their purchases. What percent of all customers receive their purchases within 4 days and are not satisfied with the quality of their purchase? Well, notice it says all customers. Okay, so the first kind of separation that we have is 80% receive their purchases within 4 days. So within 4 days, that is 80%. Then of those 80%, 95% of those people are satisfied, which means that 5% would not be satisfied. So I got to take this 80% and I got to figure out what 5% of that is. And when you do that, you will get that 4% of the people that receive their packages within 4 days are not satisfied. Okay, so notice there was kind of 2 parts there. You had to be satisfied, you had to get your package within 4 days and then not be satisfied. So we had to combine those 2 together. All right, so if you're looking at the next one, we're going to be starting to do a lot of these kind of charts with your percentages. It says an analyst researches the relationship between different energy sources for each state for 2014. The data in the table shows the number of states that use coal and nuclear power as an energy source. Given that the state does not use nuclear power, that means I'm automatically over here. We are not using nuclear power. What percentage use coal? Well, yes for coal is right here. So I have 20 using coal, but I know that they are not using nuclear power. If I put these 2 together, that gives me a total of 32. So the part that do not use coal is 20 out of the whole is 32 because they already told me they do not use nuclear power. So if you go ahead and divide that, you will get 62.5%. All right, next, given that the state uses nuclear power, so now we know that we are using nuclear power. So yes to nuclear power. What percentage of those states use coal? Yes to those that use coal. So I have 16 out of the total, which is 18, that use nuclear power. And if you divide that, you will get 88.9%. Okay, so you have to make sure you can read that chart properly. Okay, moving on here. There are a total of 500 students in grades 1 through 5 in an elementary school. 17% are in first grade, 19% are in fourth grade. The number of third grade students is 9 less than the number of fourth grade students. The number of second grade students is 10 less than the number of fifth grade students. Complete the table. All right, so let's start with first grade. I have 17%, which is 0.17 of all the kids, which is 500. So if I take that, I will get there are 85 first graders. Now I have 19% are fourth graders. So 19% of the total, that gives me 110, for the fourth grade students. Okay, so we've taken care of this, we've taken care of that. The number of third grade students is 9 less than the number of fourth grade students. So if I want my third grade students, I need to do, let's do a different color here. I need to do 110, which is my fourth grade, and subtract 9, and that gives me oh my goodness, you guys, I am so sorry. Let's go back here. I need to recalculate this. If I have 19% of 500, that will give me 95 for my fourth graders. Excuse me. Okay, so now if I want to find my third graders, I need to do 9 less than 95. And 9 less than 95 gives me 86. There are 86 third grade students. Okay. So all I have left are second and fifth. It says the number of second grade students is 10 less than the number of fifth grade students. So maybe I should figure out how many kids I have left. If I take that 500 and I subtract the students that we already have placed, let's see what we get here. That means I've used 234 kids already. So if I take 500, that means I have 234 kids left. Okay, so now when I start talking about my second grade students is 10 less than the number of fifth grade students. Well, if I look at this algebraically, I don't know anything about the fifth grade students, so I'm going to make those X. Then the second grade students is 10 less than the fifth grade students, so X minus 10. And altogether, I have 234 kids left. So if I add them together, I'll get 2X minus 10 equals 234. And now we'll go ahead and solve that. So I have that X is 112. Well, X was my fifth grade students, so that's 112. Now for my second grade students, I got to do 10 less than that. So if I subtract 10, that gives me 102 for my second grade. Now, just to be sure, I'm going to add up all these numbers, and I'm going to make sure that I actually get the 500 total. Let's see here, 85 plus 102 plus 86 plus 95 plus 112. And I got 480, which means that I got something going on wrong here. Let's take a look. 0.17 times the 500 gives me 85 first grade students. That looks good. 0.19 times the 500 gives me 95 fourth grade students. That looks good. The number of third grade students is 9 less than the number of fourth grade students. So if I take 95 and subtract 9, that gives me 86 for the third graders. Okay, so now I have the number of second grade students is 10 less than the number of fifth grade students. So let's see if I did that subtraction on the 500 properly. So that means there's 234 kids left. Oh, I made a silly mistake. Here in this equation, I should have been adding 10. I subtracted 10 instead. So this needs to be 244 divided by that 2, which will give me 122 for the 5th grade students. We're going to put 122 in there. And then 10 less than that would be 112. Okay, so now I'm going to add, and now I'm going to see if this works out properly. And there we go. We got our 500 kids. All right, so folks, this next problem is going to be a little bit challenging for us. Okay, so I want you to pay attention. You're going to need to mark down on your paper quite a bit here so we get this frequency table. So first of all, I have this frequency table. Do you see all the decimals in there? Those decimals are basically representing percentages. So if I take a look at the total, if I take this 1 and turn that into a percentage, I move the decimal place 2 spots, that gives me 100%. Okay, so if I want to take a look, I don't know, that students with blonde hair, if I move that decimal place 2 spots, that means 12.5% of the kids have blonde hair. Well, what if I want to look at blue eyes and brown hair? That would be this one. Move the decimal place 2 spots, that means 12.5% have blue eyes and brown hair. All right, so let's go ahead and take a look at this. Now you'll notice I have not been given a total number of students, so that's going to be an issue. It says in the sample there are 4 more students with brown hair and blue eyes than blonde hair. With brown hair and blue eyes than blonde hair and blue eyes. How many students total have black hair? So you'll notice that this brown hair and blue eyes, and then blonde hair and blue eyes, and I have black hair. So notice we're talking about 3 totally different things here. Okay, so I'm going to need to write myself an equation. If I want to find out how many students total have black hair, that would be over here. I've got to know the total number of students, period. So I'm going to say x equals the total number. Okay, and now I'm going to write an equation. Okay, it says brown hair and blue eyes. Well, brown hair and blue eyes is right there. Okay, so I think I'm going to write it, I don't know, maybe down here. This is brown with blue, and I have 0.125 times x, because that would be my total. That would give me the number of kids that have that. Now let's go blonde with blue, which would be blonde with blue is this one right here, 0.075 times x. That would give me my number. Now it says there are 4 more students with brown and blue than blonde and blue. So if I wanted to set them equal, brown and blue have 4 more. So if I want them to be equal, I can do 2 things. I can either put a -4 over here to make them be equal, or if you don't like that way, we can also put a +4 over here to make them be equal. It doesn't matter. Okay, so I think I'm going to go back and I'm going to do it this way. I'm going to say if I take my brown and blue and subtract 4, it should be equal to my blonde and blue. And then we'll go ahead and solve. Okay, we'll get our x's together. So if I move this over, this gives me 0.05x is equal to, move that 4 over and it gives me 4. Now when I divide, I get x equals 80. So that's the total number of kids in the survey. So if I want to know how many have black hair, I need to take that 80 and multiply it by the 0.250, which will give me that 20 kids in this survey have black hair. All right, let's do another one like that. So I'm going to go ahead and I'm going to get rid of all this. So pause it if you need to and write it down. But I'm going to go ahead and get rid of all this because we're going to go on to another one. All right, again, this is a new sample. So I'm going to say I don't know how many total I have. I want to know how many have blue eyes. Well, blue eyes is right down here. So once I figure out the total number, I can take that total number and multiply it by 0.20. We are talking about 42 less students with black hair and brown eyes. So black hair and brown eyes. Let's see what that number is. Black hair, brown eyes. So we have 0.225. That'll give me the total there. and then students with brown hair, period. So brown hair, period, is right over here. So just brown hair. So that would be 0.575. Now they told me there were 42 less students with black hair and brown eyes than students with brown hair. So if I want to make these things equal, I can do two things. I can either say if I want them to be equal, I would have to add 42 to this to make them equal. Or I would subtract 42 over here to make them equal. Either way is good. I think I'll go ahead and leave it like this. If I solve this and I move my x over and move the 42 over, the 42 would come over here. My x's would move over here. Now, if you're having problems with this, show your work. If you moved it over and have negative 0.35 and negative 42, that's okay as well. When you divide, you get 120. So that's my total surveyed for this question. So I'm going to take this 120. Whoops. Let's go back to my red here. I'm going to take this 120 and I'm going to multiply it by the 0.200, and this will tell me there are 24 students with blue eyes. Now, folks, you might have to go back and view that explanation for this question again to look at it and see how we do. Okay, that's a little bit more difficult of a question. All right, so when you're finished, you can go ahead and do your notes check, and I will see you tomorrow.